You probably remember these old games or these old keygens where when you open the executable, instantly a melody plays, and it's just so nostalgic. And I'm trying to figure out how to do that in C. So I was playing around with the SDL library a bit, and when trying to implement audio, I was actually quite lost, and I'm still very lost. So I would like to take you onto this journey and just try to figure out together how SDL audio is supposed to work. So I will create an audio.c file and include SDL to SDL. That should be the library that we need. And then I'm going to create a main method. And all we're trying to do in this video is we're going to try to play a WAV file. So we're going to try to play a pre-recorded WAV file, which is this one right here, which I recorded earlier. Yeah, so that's what I'm trying to play in SDL via, well, our C code. And let's try to compile that using the using the SDL compilation command. If we pull up the SDL documentation, then you can find that command somewhere in the introduction. I'm using SDL2, so you have to be careful there. There's a bit different command for SDL3. And it's available in the installation, and we need to do this command right here. So we need to provide this part with the compilation program. So we're going to compile an audio executable of the file audio.c, and then we're going to compile that. That does not work. Why? It doesn't work because the header that I included is wrong. Probably something is included wrongly. It's either SDL2 SDL or it's SDL. Maybe it's SDL.h. Oh yeah. Okay, and that seemed to execute, so it must be SDL.h. Then the first thing that we need to do, there are multiple ways apparently to play audio via SDL, but I'm trying to find out the simplest possible way, and that seems to be via this function queueAudio. And the description of this method says queue more audio on non-callback devices. So there's another method that somehow calls a callback and pulls more audio data from your callback method, which is very confusing in my opinion. In my opinion, if I want to play sound in a software, all I should do, or all I should have to do, is specify the file that I want to play and then just play that. So it should be play music, and then the parameter should be music.wav, the file name. But okay, we're in C, we're in SDL, it's not going to happen. The first thing that we then need to do is we will have to initialize the audio subsystem. So in SDL, SDL is a library for multiple subsystems. And we have to, in the beginning, specify which subsystem we're using. So we can use this method right here, which is init subsystem, this one. Okay. And then we have to specify a flag, one of the SDL init flags, and there are multiple such subsystems. And depending on what you want to use, your camera, sensors, events, whatever, you specify that. We're going to use the SDL init audio subsystem. And that should be it, at least regarding the initialization of the system. And then what we should need to do, according to this Reddit commenter here, he said that all we need to do is we need to load the wave function using SDL load wave. Load wave is a macro, which wraps this existing method load wave RW, whatever that is, read write, I don't know. But this macro here you can specify a file name, and well, we have to confirm whether that's just the file name, and then a couple more variables. But let's have a look at the load wave RW, because that seems to be where the parameters are defined. Ooh, what kind of documentation is that? Okay, that is the load wave RW that we are going to call via load wave, and it's going to call this utility method here. So let's look that up, and it's going to take a file string and a file mode. The file string is a UTF-8 string representing the file name to open. Okay, so that's straightforward. So that means that is the file name. Then let's just start coding that. The file name that we're going to play, the file that we're going to play is called sample wave. And let's find out what the other variables are. Spec is a pointer to an audio specification. Passing a pointer into a method means that the method is probably going to somehow fill information here for us. I'm not sure if we need that information, but let's just declare that variable and keep it empty. Then let's just copy these two variables as well. We're going to need them as well. That's interesting. Audio buffer is a double pointer. It's a pointer to a pointer. A pointer filled with audio data allocated by the function. Allocated by the function, yeah, so that's something we don't have to care about now. But why is it in a pointer filled with, well, it's a pointer to data. It's a pointer maybe to arrays. I'm not sure about that, but let's just ignore that. Let's just get this method properly executed. And here we have to then specify all these variables just as they are. I think now let's do this. We're going to remove those pointer operators. Now let's pass the addresses here. So this might be a bit clearer also to me. So this will be the audio buffer and this will be the audio length. Yeah, that might be a bit clearer. Now we have a specification. We pass the address of the specification to the method so that the method can then manipulate the specification. We initialize a uint8 pointer, which is the whole set of audio data. And then we pass a pointer to that into the audio buffer. Yeah, so now it makes sense. And then we have the audio length, which is a uint32, and we pass the address of that into the method so that the method can fill it for us. So far it's clear, I think, and we should be able to compile that. And what I'm missing is a file that I would like to put in here. I know that I have created this file here. Let's copy it over. Okay. And executing it does nothing. Yeah, as expected, because we just opened the file. But maybe let's get some feedback from the load audio method. Specifically because it returns an audio specification. That oh no, that's not really good feedback, I think. It is good feedback because we can check for null. So we can do... Wait, it is expecting a specification and then it's also returning a specification. That is a bit confusing. I think it enters the information also into this specification here. So the return value and the method parameter are going to be the same. Return spec, which will be filled with the audio data. And the method returns null. Yeah. Okay, then let's do this SDL audio. Oh, something's wrong with my Vim. X mode, visual. SDL audio spec return spec, and that is equal to this, to the function call, and we will receive a pointer to a return specification. So let's declare it like that, and then we can check if that is null. If return spec is null, then we can printf error opening the specified file. And to printf, we have to also include a new method that is going to be standard, or a new header library that is going to be standard.io.h. So now we're loading the file, and if the return specification is null, then we printf that it worked, and let's just also printf that the audio file was successfully loaded. And let's get some feedback from the compiled audio command. Yeah, audio file was so audio file was successfully loaded. That is great. I missed adding the new line characters here, which I always do when working with C. So let's compile again and execute the audio command again, and the audio file was successfully loaded. So that's great. So now we have a loaded audio file, and now we should be able to use some of what we already prepared to queue this audio file. So now we queue more audio on non-callback devices. Yeah, let's see how we can use that. We have now opened the file, and through opening the file, we should have access to the data. Yeah, it might be this audio buffer. Then this is SDL3, this is SDL3. Okay, then in SDL queue audio, we have to queue the audio data and the length on a device. So let me just copy that, and we can then step by step fill the method call. So first of all, what is the device that we want to use? Let's check out what the device is. SDL audio device IDs. Okay, a successful call to SDL open audio, which is what we just used. No, we used SDL load wave. This function is a legacy means of opening the audio device. No, that's not what we need. As always, device ID 1. And legacy SDL audio APIs assume you want this device ID. SDL open audio device calls always return devices. Always returns devices. To unsuccess. Legacy calls are good for both backwards compatibility and when you don't care about multiple specific or capture devices. I don't care about multiple specific or capture devices. Function is legacy means of opening the audio device. And here we specify two audio specifications, the desired and the obtained. I don't have a desired audio specification. Maybe we can specify or pass the same specification there. What is used here? If it's not too hard, we might as well also open a specific audio device. I'm just not sure whether that's too much. So we have to open an audio device, and that returns an audio device ID. And using that audio device ID, we can then queue audio on that device ID. Let's try that. Ooh. Playing music in SDL is really not straightforward. Okay, we are getting an audio device ID. Then we are calling SDL open audio device, and we're passing into it a device that we want to use, but we don't want to use one. So I just saw in the specification, in the documentation, that we can pass null here. Is it a capture device? No. Non-zero to specify a device should be open for recording. So we pass 0 or null, which is the same. But since they use the word 0 here, I'm just going to pass null as a 0. The next step is the desired audio specification. And I think here we can just pass the same audio specification that we received in the return specification twice. I'm not sure why the desired audio specification is a constant and the obtained is not. I don't think it makes a difference for us now. Let's just pass the same return specification here and pray that it works. Because from my understanding, the return specification is exactly what matches this audio file. So we don't need to tinker with it. And then we can use we have to set allowed changes 0 or one or more flags ORed together. What is that? Allowed changes. Allowed changes. Can have the following flags ORed together. Frequency change, format change, channels change, samples change. Why should we change anything? If your application can only handle one specific data format, pass 0 for allowed changes and let SDL transparently handle any differences. Let's just pass a 0 and then have a look whether we mess up or we don't. Then, next step, we can cue the audio. So now it's getting interesting, and now we have to supply the audio data. That means, where is the applicable documentation? The data to cue the device for later playback. That is the data. The data to cue the device. Should we just provide the audio buffer here? I think we can just provide the address, since here we have a data pointer, a pointer to void, and here we can then probably just specify the audio buffer. It is probably void because in the specification we really specify which data type our audio stream has. So this is a means to be flexible in this method signature, I think. But yeah, I'm not sure. And then we provide a uint length, that is audio length. And I would say, let's do a couple more checks. So if our device is null, then I'll just copy these print statements here. Oh. And here we will specify if the device is null, then we can alert error reading the device. New line. I'm not forgetting it this time. And then here we can specify device read successfully. Well, not read. Opening the device. Opened. Whatever that specifically means. And now we can cue the audio here. Does this method return anything? Yes. It returns an integer on success or negative error code on failure. So int cue audio result is, can we just paste that? Can we just paste that here? Oops. I'm just doing it like that for now. So if the result is 0, then we can print. Let's just copy these print statements again. Success queuing. Well, I hope this is not a typo. Queuing the audio. Full stop. And here, failure. Queuing the audio. New line, full stop. Okay, let's compile that. We have read the device, we have queued the audio, and I think we are now ready to compile. Okay, something's wrong. If def is equal to null, so that doesn't work. Comparison between pointer and integer, so null is a pointer only or what? But I thought that this is a valid comparison here. What are we doing? We are opening the audio device. So let me just pull up the documentation. Open audio device is this method. It's returning an audio device ID. And that audio device ID is, what is it? It's a uint32. Okay, and it's 0 on success or 0 on failure? Huh? What does that mean? 0 on success or 0 on failure? Maybe negative on failure. Maybe this is a typo in the documentation. Zero on success or 0 on failure. I don't know what to do with that, so let's just delete these log statements. Let's try. If I'm correct, if this implementation was correct so far, then this should now play audio. Ooh, segmentation fault, great. Where is the error? I will add a log that says device ID is, and that is a number. Like that. Let's see how far we get. Device ID is 2. Segmentation fault. Okay, so the error happens after queuing the audio. So we're probably using queue audio wrong. We are queuing audio here on the device. We're providing a pointer to the data. Oh, we might not have to use the address here and can just provide the data itself, because this is a pointer. This is just a pointer, and the audio buffer is already a pointer. Let's try that again. Okay, success queuing the audio, but it immediately exited. So maybe we have to wait for the audio to play somehow. Is there a wait function for audio? I know there was a wait function for SDL. Let's see. SDL, was it just SDL wait? Wait thread, wait event. No, that's not it. Let's have a look at the wait function we used in the Pong game project. SDL Pong. I think we waited here. Waiting. SDL Pong. Where's the delay? SDL delay 10. So we might have to specify a delay. Let's just try that. I'm not sure if that is the right solution. Probably not. But let's just do it. SDL delay. And this will play for 10 seconds, 10,000 milliseconds. Okay, I don't hear any audio. Success queuing the audio, but why does it not play anything? I mean, we can play the file. Yes, we can play the file. Queue audio. Is queue audio the same as play audio? I think so. This will queue audio to a device. The function copies supplied data so that you're safe to free. Okay, we might have to unpause the audio device. So we have loaded the audio to the. Well, we have loaded the audio. Then we have queued the audio, and now we have to activate the audio device by unpausing it. So to do that, we have to call pause audio device, specify the device, and then specify 0. And 0 is a flag that specifies that we unpause the device. And now we can use SDL delay to just check if it works. Let's see. And it works. That's great. Okay, so that was the issue. So as a next step, we can play this either for a fixed amount of time, in this case 10 seconds, or we can actually calculate the audio length, which is, well, you would have to get the frequency from the specification and the audio length of the stream and all of that. That's not what we're going to do now. This is completely enough for our purposes. And in the end, you have to do SDL close audio device and SDL free wave to free the storage. And then let's call SDL quit. So that is all the cleanup stuff. And that's how you play audio using SDL. Yeah, great. Okay, so I hope this was helpful. At least, troubleshooting together with me and finding out some stuff about the SDL library. For me, it was very interesting, and I learned that using SDL to just play back audio is hell on earth. If you like this, then please leave a like and subscribe to this channel, and let's see you next time. Bye.